दुखी क्यों साउंड कर रहे हो?
नहीं, कोई दुखी नहीं। आप कैसे हो?
मैं बहुत अच्छा हूँ। आज तो देखो मैं अपने ऑफिस से क्लास ले रहा हूँ।
हाँ। हम कब आएंगे कॉलेज?
तुम लोगों का मैंने सेकेंड ईयर हो ना? हाँ, मैंने कल ही पता किया था। तो एक्सपेक्टेड दैट बाय एंड ऑफ मार्च your batch would also be invited to come to the campus by end of March. So
आज मीटिंग है सर।
yes, we know. कल मुझको मानिक लाल मिले थे। तो मानिक लाल इज डीन एपी। तो उनसे मैंने पूछा था तो उसने कहा था कि फर्स्ट लेट थर्ड ईयर कम, व्हेन दे सेटल डाउन देन वी विल कॉल सेकेंड ईयर। तो तुम्हारे सीनियर्स पे डिपेंड करता है कि तुम लोग कितने जल्दी आओगे। तो उन लोगों को बोल के रखना कि साहब आप लोग बदमाशियां मत कीजिएगा, थोड़ा वेल बिहेव्ड रहिए सो दैट हम लोगों को भी बुलाया जाए। हु इज एस एस जी? एस एस जी मोबाइल फोन से उसने ज्वाइन किया है। एस एस जी इनिशियल किसका है? एस एस जी।
हेलो सर।
यस सर, कौन है? कौन हो तुम?
सर वो SSG।
क्या नाम है तुम्हारा?
समीर।
सो व्हाट डज एस एस जी स्टैंड फॉर?
गोठानिया समीर।
तो फिर एस एस जी कैसे है?
सर
धनिया।
लाइक समीर सुकापाई गोठानिया से।
अच्छा। तो कहाँ रहते हो तुम?
मैं पोरबंदर में, गुजरात।
पोरबंदर। गुड। वर्षिल नायक। वर्षिल। वर्षिल नायक कौन है? बोलो भाई, वर्षिल। नहीं, लॉगिन करके निकल लिया घूमने। वर्षिल नायक। एब्सकॉन्डिंग लिख रहा हूं मैं इसका। ठीक है, फिर पुलिस स्टेशन से खबर जाएगी उनके पास।
हेलो।
ईशा।
हेलो
ईशा
सर।
शाह। ईशा शाह।
हेलो सर।
यस सर।
ईशा आप कहाँ रहती हैं?
सर मैं आनंद से हूँ।
आनंद।
सर हेलो सर।
कौन हो भाई?
सर वर्षिल हियर।
कहाँ गायब थे?
Sir, my mic was not working in my PC, so I joined from my mobile.
हाँ, बट गायब कहाँ थे? मैं इतनी बार आवाज लगाया।
Sir, my mic was not working in my PC, so I joined from
अच्छा।
mobile.
अच्छा।
हाँ।
बट तुम्हारा तो नाम नोट हो गया एब्सकॉन्डिंग।
Sorry, sir, but mic was not working.
मेघा, मेघा बेन राठवा, राठवा। मेघा,
यस सर। यस सर।
कहाँ रहती हैं मेघा?
सर छोटा उदयपुर।
अच्छा, छोटा उदयपुर, ये लवली
Yes.
प्लेस। वहां पे अभी भी वो चल रहा है, एक भाषा करके एक एनजीओ चलता था छोटा उदयपुर में।
नहीं आइडिया है सर मुझे कोई वो।
अच्छा, कितने साल से रहती है तुम छोटा उदयपुर में? तेजगढ़ नाम की जगह उधर ही है ना?
सर परमानेंट बॉन्ड ही यहाँ पे।
तो तेजगढ़ नाम की
यस सर।
जगह, तो हाउ फार इज दैट प्लेस फ्रॉम योर हाउस? तेजगढ़
सर अराउंड 20 किलोमीटर। 20 किलोमीटर।
वहाँ एक बहुत खूबसूरत सेंटर है, लैंग्वेज स्टडी तो नहीं है,
हाँ
ट्राइबल
वैसा
लैंग्वेज।
मैंने पहले सुना था। हाँ।
अभी तक गई नहीं हो?
हाँ शायद अभी भी चलता है सर वो तो।
अभी चलता तो है, तुम गई हो या नहीं गई हो कभी? इज अ लवली
नहीं
प्लेस,
सर मैं नहीं गई हूँ वहाँ।
एक बार जाओ,
ओके आई
बहुत
विल
खूबसूरत
विजिट।
जगह है।
या।
मतलब दैट सेंटर इज ऑल्सो वेरी गुड एंड दैट प्लेस इज ऑल्सो वेरी ब्यूटीफुल। बिल्कुल एक माउंटेन तो नहीं कहेंगे, एक हिलॉक के बैकड्रॉप में बना हुआ है। अच्छा है, और वहाँ फ्री फ्री का खाना है, जाओगी तो लंच कराएगा फ्री में। मैं मतलब एक देर वॉज अ टाइम जब कराता था, अब क्या कंडीशन है उनका मुझको नहीं मालूम।
हाँ मैं भी नहीं गई हूँ अभी तक, जाऊंगी अब।
धोनी नाम के दो लोग हैं, धोनी उपाध्याय एंड धोनी जसवंत भाई समथिंग। तो धोनी,
हेलो सर।
सो यू आर
गुड
धोनी
आफ्टरनून सर।
गुड आफ्टरनून, तुम धोनी उपाध्याय हो
यस सर।
एंड देयर इज वन धोनी चौधरी।
यस सर।
वो कौन है? धोनी चौधरी?
Yes, sir.
हाँ, तो धोनी चौधरी कहाँ रहती हैं और धोनी उपाध्याय कहाँ रहती
सर मैं अहमदाबाद में रहती हूँ।
और मैं सूरत में।
हैं? हु इज दिस मैं? पहली वाली मैं थी
ध्वनि
उपाध्याय।
चौधरी।
धोनी चौधरी रहती है सूरत में
यस सर।
और उपाध्याय रहती है अहमदाबाद में। अच्छा, अहमदाबाद में तो मैं भी हूँ। गुड, चलिए तो शुरू करते हैं आज की पढ़ाई हम लोग। इट इज 12:08 and 225 students are here. Share screen, share। फिर क्या करूं, इसको बंद करूं, स्टॉप वीडियो। Then fine. So in the last class we were looking into how atoms interact. What we did, we took reference from what you studied in your electromagnetic theory the last semester. We started with single atom, force-free space, presence of that single atom. Then we brought second atom. Then we brought third atom. So the potential experienced or work done in bringing second atom was something, but work done in bringing third atom is different from the first atom, from the second atom. So in that way, we started calculating overall work done in bringing many atoms in the same space. That space could be a surface also, and that space could be a volume also. So if you are to calculate the work done in bringing a charge density rho, so atoms which have a charge density rho in a volume V, then that work done is equal to half of integral of rho V d tau, where d tau is the infinitesimally small volume element on which you are integrating. And this is considering that the charge distribution is continuous. If the charge distribution is not continuous, discrete, then this integral sign will be replaced by summation sign from 0 to n atoms, which you are bringing in and which has that volume charge density rho. If the assembly is done on the surface, then the work done is sigma V times dA, where sigma is surface charge density, V is the potential V, and dA is infinitesimal on surface element or area element on which you are integrating. Okay. So if these two atoms are quite separated, then they will behave as if they are isolated atoms, and their charge distribution wave function can be plotted like this. But when many and many atoms are brought together close to each other, then the situation changes. And that situation we were talking about, or we were in the last slide of last class, was this, in which we were trying to look into the situation when many atoms come closer to each other, whether they are going to follow Pauli exclusion principle or not. By Pauli exclusion principle, we know that no two electrons can occupy the same space, same energy space or same energy level. So each electron has a unique energy level. And in such circumstances, if we bring many atoms which have certainly many electrons, then how these electrons are deciding which place which electron will occupy. And I gave you the example of a typical classroom, that if there are many benches or many seats in the class and less students, so visualize these students as electrons and those benches or seats as those energy level, allowed energy levels, then electrons can occupy any place. But if there is a teacher standing there, so teacher, you can think in terms of nucleus, then the teacher would ask you, come closer. So sit on the first bench. So that is n is equal to 1. So all electrons will occupy in presence of the nucleus, all electrons will start occupying energy levels which are closer to the nucleus, because that is the minimum energy level, or that is the most stable energy state of the atom. So that way you start filling up all the seats. But when electrons are more than allowed seats, then what will happen? Or available seats, then what would happen? Then each seat will stretch itself, or each student will squeeze himself or herself to accommodate another student, another friend of his or her. So that way, that is what we call in atomic structure or in molecular structure or in a cluster formation of atoms, we call it splitting of energy level. Because certainly, regardless of how many atoms are there in the same space or same volume, electrons, two electrons cannot occupy the same state, same energy level. So this is that diagram that we were looking into in the last class, and I told you to come back in the next class after studying about this. So can anybody tell me what this energy diagram conveys? What this energy diagram conveys? कोई देख के आए? नहीं? Very good. Very good. Okay. No problem. So here you see that at the top I have, or this in this figure, this is not created by me. So on the top there are 4 boxes written N, L, M and S. If you recall, in the last class I also asked you what are the 4 quantum numbers. So these are the 4 quantum numbers which, these are the 4 quantum numbers. This is principal quantum number, this is angular momentum, this is magnetic moment, and this is spin quantum. And these are all atoms of all electrons of one particular atom. So this is n is equal to 1, so it is 1, n is equal to 1, and there are 2 electrons, you know, so 1 s2, and those 2 electrons have plus and minus spin. In n is equal to 2, now there are 2s2, 2p6, so 8 electrons. And how they are distributed? That for principal quantum number 2, there are 0 and 1, 2 L state, and there are 0, minus 1, 0, plus 1 M state, and each of these M states would occupy 2 electrons of up and down spin, so plus and minus half. So this way there are 8 electrons which are accommodated in n is equal to 2. And then there is n is equal to 3, third orbit also. The third orbit, 3s2, 3p6, 3d, nahin, sp, d. So this is S, this is P, this is D, yes. And these are the electrons which can occupy separate energy levels in that isolated atom. This is one isolated atom. But now we are thinking of a situation where we have actually brought n such atoms very close together, very close together. And since there are n such atoms, therefore for each atom there are in outermost orbit or n is equal to 3 orbit, there are 2 n states, and in P there are 6 n states. So P state, P orbital can take a 6 electron each, and there are n such atoms. So there are 6n. So 6n seats are available in the class. Okay. This particular atom which we are talking about is silicon, which has 2s2, 2p2. So this is third 3s2, 3p2. So this is s2 electrons of s orbital, and these are 2 electrons of p orbital. However, p has 6 vacancies or 6 separate distinct energy levels, but in this atom there are only 2 p state or p orbital electrons. So 6 n states are occupied by only 2 n electrons. In case of n silicon atoms brought together or put together or fixed together in one small space or volume, right? So this concept is very important for you to note, that there are six n. N is number of atoms brought together. There are 6 n seats available in that class for latecomers. Okay, but only there are 2 n latecomers. There are many vacancies in the outermost orbit. However, the inner states are already occupied. So 3s is completely occupied. This 2s, 2p completely occupied. 1s completely occupied. And there is a back door entry, and from that back door there are 4n students who joined the class late, 2n occupying the 2n states of s orbital, and 2n, other 2n students are occupying the 6n possible seats of 3p state. So this is the meaning of this diagram. Now if we are bringing these 6n atoms still closer, then what would happen? That we are going to discuss. So this is your silicon whose Z is equal to 14. If I ask you to write the electronic configuration of silicon, then it is 1s2, principal quantum number n is equal to 1, 2s2, 2p6. So second principal quantum number state is also completely filled, but in the third, remaining 4 electrons will occupy the third orbit, which can accommodate more than 4 electrons. But since there are only 4 electrons, so these 4 electrons are occupying 3s2 and 3p2, and there are n such states. This is for one isolated atom. But what we are doing, we are bringing n such atoms close to each other. So basically I have 2n states of 1s, 2n states of 2s, 6n states of 2p, because p orbital can occupy 6 electrons and there are 6 electrons in each atom, and therefore 6n benches or seats are available for 2p, 2n are available for 3s, and 6n benches or seats are available for 3p for n silicon atoms, right? These n atoms come closer and closer, and their interatomic spacing decreases, and therefore now these electrons are actually competing with each other. And Pauli exclusion principle is regardless of anything applicable. So these electrons actually are adjusting themselves within the allowed energy levels of isolated atoms. So those energy levels are now splitting, stretching themselves. And those stretched or splitted energy levels are now called energy band. Energy band. So the energy level concept stands good for an atom, and energy band concept holds good for a solid or a crystal state, in which we are actually putting many atoms very close to each other so that their interatomic space decreases considerably. And the formula that you just deduced yourself from your earlier knowledge of electromagnetic theory, that how much work is required to be done to bring all those atoms close to each other so that they would stay stable. So that they would stay stable. अगर stable नहीं है तो crystal रहेगा नहीं. So till it occupies minimum energy level. ये देख रहे हो एनर्जी कम हो रही है यहाँ पे. So till the energy is reducing, these atoms can come closer और उसके बाद फिर नहीं रहेगा. फिर उनको न्यूक्लियस, उनके दोनों के न्यूक्लियस आपस में रिपेल करना शुरू करेंगे एंड द क्रिस्टल विल ब्रेक अवे. So the question here is that if the splitting has to start, which orbital will split first?
Sir, the outermost orbital will split first.
So in the case of silicon, in the particular case of silicon, इसमें ये Z is equal to 14. So now you tell me which orbital or which energy level will start splitting first?
3p2.
3p2.
3p.
Okay. But the difference of energy in 3p and 3s is quite small. So it so happens, yes, your answer is correct, that it is 3p which will start splitting first, but simultaneously 3s will also start splitting because the difference between these two are very, very less. So 3p will influence 3s also to split. And the situation that occurs is like this. Look at, we are coming back to the same diagram, and this is, so this is your 3s, 3p, है ना? इसमें 6n states available हैं, and this is your 3s, which has 2n states of n atoms, 3s state of n atoms. So both will start splitting almost simultaneously. ये ऐसे split हो रहा है and this will split like this. एक नीचे आएगा और एक ऊपर जाएगा obviously. Till the lower part of 3p and the upper part of 3s join, meet. The moment it happens, what you get is that there is no distinction between what is 3p and what was 3s. These two are merged now. यहाँ देख रहे हो, यहाँ पे there is no differentiation. So basically, what is happening that this is called hybridization. When these 3s and 3p both split such that these two merge to each other. So this is 3s or sp hybridization of energy levels. So what will happen? This is the situation. So this shaded area by yellow color, transparent yellow color, is that hybridized state of sp. So meaning what? Meaning that there are 6 plus 2. So there are 8n states, 8n benches or seats, chairs available in the class, which will be occupied by 2n plus 2n. So 4n students. There are 8n chairs which will be occupied by 4n students. This is that meaning of hybridization. This is the meaning of hybridization. But consider a situation that the teacher or lecturer's voice is so feeble that day the teacher is not good in health, and so his voice is not audible to the last energy level or to the last chairs or to the last benches of the class. So what is happening, that again each atom will try to come closer and closer. So that पीछे के बच्चे भी जो लेट, जो हायर एनर्जी लेवल के जो बच्चे हैं, वो भी आवाज सुन सकें न्यूक्लियस की, वो भी न्यूक्लियस से अट्रैक्टेड रहें. They also want to be bound with the atom. They don't want to escape the atom. So वो और टाइट हो रहे हैं और क्लोजर आ रहे हैं. When it starts, then what actually would happen, that again there will be a splitting that would start happening of this hybridized state. That splitting is basically, this line is tending to go up and up, and this line, तो नेचर वही है, ग्राफ वैसे ही अपना बढ़ रहा है. ऊपर वाली लाइन ऊपर जाते जाएगी, इसकी 3s के लोअर लाइन will start going lower and lower. 3p lower line will start coming, will continue coming lower and lower, and 3s upper line will keep growing higher and higher. So after this hybridization state, again there is a splitting that you are seeing here, and that splitting is actually, so this is one part and this is another part. तो हो क्या जाएगा कि उस क्लास में फिर two bunches are now created, or two groups are now created. But the thing is that in that creation of bunch, since by nature all electrons would try to remain in the lowest possible available energy state or energy level, so all those 4n electrons or 4n students will take seat in that lower bunch, lower group of chairs, which is closer to nucleus, let us suppose. And the upper 4n state, because earlier there were 8n states, यहाँ पे जब हाइब्रिडाइज हुआ है तो 8n स्टेट है मेरे पास and 4n electrons है मेरे पास. So half states are here empty and half are filled. But on further splitting of these two energy states, what is happening is that the lower band is now completely filled by all those outermost electron, and the upper band is completely empty. There is no electron available. And by virtue of this type of splitting, what you are seeing is that this is a gap that is created. Here there is nothing. This is called energy gap or band gap और disallowed energy state. यहाँ पे कोई इलेक्ट्रॉन नहीं रह सकता है, एनर्जी है वहां पे. If you pass through that space, you should have that much energy, but you cannot stay there. It's a no parking zone. No parking zone is always empty. So you are tempted to park your car there, but it is legally not allowed. So even though there is a space, empty space, have to drive your car through that space to some other parking place where there are space. If you are looking for parking in, let us say, अहमदाबाद मॉल या क्या नाम है उसका, यस नहीं अहमदाबाद 1 अल्फा 1, कोई एक मॉल है वहाँ के पास अगर आते हो और सैटरडे संडे बहुत रश रहता है, तो इफ यू डोंट गेट पार्किंग प्लेस, if you find that parking is full, then you cannot enter there. Even though on road you will find there are some space available, but you cannot park because two-away trucks are moving there. तो अगर आप किसी गलत जगह पे पार्क कीजिएगा तो आपकी कार उठा के ले जाए. So now you have to go all through this area to this place where there are chairs, there are space available for parking your car, and you have to park your car here. So this space which is created because of splitting of energy levels, when you are trying to bring n atoms close together to form a crystal, is known as band gap, which is a disallowed energy level. तो जब क्वांटम मैकेनिक्स या क्वांटम मैकेनिक्स के लॉज को फॉलो करते हुए व्हेन यू स्टार्ट स्टडिंग, देन यू फाइंड दैट these are the states which are not allowed. So forbidden energy level is the name of given to this, or energy gap, EG. We note it by EG. So when you find these two separate energy bands, when you bring atoms still closer, then the upper band is called as conduction band and the lower band is called as valence band. And by virtue of this particular atom के केस में मैं बात कर, सिलिकॉन के केस, it so happens that the valence band, all 4n allowed states of valence band are occupied by 4n electrons of silicon, and all 4n allowed states of conduction band are completely empty. 0 electrons are there. This is a very, very peculiar or particular characteristic of group 4 element, जर्मेनियम, सिलिकॉन, कार्बन, जिसके मेंबर है. And this group 4 is called semiconductor material, जिसकी हम लोग बात आगे करेंगे. And therefore in the foundation we try to understand what is the unique property of this group element. And the unique property is this, that valence band at zero temperature, so absolute zero temperature, not at room temperature, at absolute zero temperature, all 4n valence band states are completely occupied by 4n outermost orbit electrons. All 4n allowed energy states of conduction band are completely empty. और ये कंडक्शन बैंड और वैलेंस बैंड के नीचे जो बैंड है, नीचे भी तो है ना, ये जो प्रिंसिपल क्वांटम नंबर 1 और प्रिंसिपल क्वांटम नंबर 2 वाले जो है, इसमें 2 इलेक्ट्रॉन है, इसमें 6 इलेक्ट्रॉन, 6 2 8 इलेक्ट्रॉन है. ये तो नीचे में है ही है. तो दीज आर कॉल्ड कोर बैंड या कोर एटम. इसमें यहाँ पे इफ यू नोटिस हियर, you see that in the second level also there is a splitting which has started, but this happens much later when you still try to put some more atoms in the same space or volume, then even level 2 will also start splitting. But forget about that. That is not of our concern. We are happy with the splitting of third state only. Okay. So at absolute temperature, all possible places in valence band are completely filled, and hence there is no vacancy for electrons to move around. जितने चेयर हैं उतने लड़के बैठे हुए हैं. तो अब अगर कोई और आता है तो वहां तो नहीं आ सकता है बैठने के लिए, अब उसको कहीं और स्पेस लेना, सीट लेना पड़ेगा. So now it has to go to conduction band. So मान लो conduction band is not चेयर, so discrete levels वहां पे नहीं है सपोज, कंटिन्यूम में, तो आपको नीचे बैठना है, वहां चेयर है ही नहीं, आपको जमीन पे ही बैठना पड़ेगा. So if you are so late, then kindly sit on the floor. That is that state. In energy terms, conduction band always remains at equipotential. इक्विपोटेंशियल है, तो वहां जो भी इलेक्ट्रॉन आएगा उसको जहां मर्जी वहां जा सकता है बिना किसी एक्सटर्नल वर्क के. इफ इट गेट्स अ सिंपल पुश, it can move within that conduction band freely. तो ऑलमोस्ट कंटिन्यूम वाला स्टेट है वो, ऑलमोस्ट, नॉट एग्जैक्टली, ऑलमोस्ट कंटिन्यूम वाला स्टेट. क्योंकि 3 के ऊपर 4, 5, 6 जितने भी प्रिंसिपल क्वांटम नंबर के स्टेट हैं सब उसमें आके मर्ज कर रहे हैं, एंड above that everything is in continuum. It is like a sea surface. एक बार आपने पेपर बोट उस पर डाल दिया तो वो अपना घूमता रहेगा वहां. There is no traffic light, there is no rule, there is nothing. So Newton's first law of motion will be applicable. जब तक कोई और चीज फोर्स उसको रोकेगा नहीं तब तक वो अपना घूम चलता रहेगा, या अगर रुका हुआ है तो अपनी जगह पे स्टेट ऑफ रेस्ट में ही इट कंटिन्यू टिल इंफिनिटी. So that is conduction band. But in valence band, it is packed, jam packed. There is no space, no electron can move. And therefore, absolute zero temperature, this is a perfect insulator. This material is perfect insulator. इलेक्ट्रॉन मूव करेगा ही नहीं, इलेक्ट्रॉन मूव नहीं करेगा तो करंट फ्लो होगा ही नहीं, बिकॉज dq by dt is your current I. तो रेट ऑफ चेंज ऑफ इलेक्ट्रॉन और नेगेटिव चार्ज कुछ होगा ही नहीं. So there is no current. Since there is no current, so it is insulator. It is not allowing any current to flow. But think of a situation, what happens when temperature rises? ये तो हमने बात की absolute zero temperature पे, which is very rarely to achieve. अभी हम लोग जैसे बैठे हुए हैं, that is not zero temperature, that is a room temperature. पता नहीं कितना होगा, 17, 18, 20 डिग्री होगा टेम्परेचर आपके कमरे का. कमरे के बाहर हो सकता है 21 डिग्री हो, 22 डिग्री हो. There is some temperature. Since there is some temperature, so there is some energy or heat energy है वहाँ पे. Heat energy के कारण particles or gaseous particles are scattering here and there, moving. Nothing is still. एनर्जी ट्रांसफर तो हो ही रहा है, मॉलिक्यूल्स घूम रहे हैं एयर. So what happens when temperature rises? This happens. So basically in a solid structure, what is the situation is that these black circles or spheres are basically atoms. All these atoms are, this is called phonon model of atoms or of solid. So all these atoms are basically interacting such that these are pendulums. The interaction energy or process of interaction is as if these are connected with a spring. So when this atom comes right, then it compresses this side and it releases this side on its left. So compression energy जहां पे आया वहां पे हीट बढ़ गया, वहां ज्यादा एनर्जी आ गई. जहां पे रेयरिफिकेशन हो रहा है वहां पे हीट कम हो गया. बिकॉज ऑफ दिस डिफरेंशियल लॉ ऑफ एनर्जी और हीट within that solid structure, these atoms are always mobile, even though we say that these are fixed. So basically they are fixed around their position x is equal to 0 or y is equal to 0 or z is equal to 0. But actually they are pulsating, they are vibrating on their positions, each atom randomly on some direction, and therefore they are actually bound. With that interaction energy, they are bound. So I have given you an example again to visualize that. Let us visualize the crystal of NaCl, जो तुम्हारा टेबल सॉल्ट होता है. NaCl में there is ionic bond. Ionic bonds are the strongest bond. So Na plus और Cl minus से ये बना है. तो Na ने अपना जो आउटर मोस्ट ऑर्बिट का जो सिंगल इलेक्ट्रॉन है वो दे दिया क्लोरीन को. Therefore Na became Na plus and Cl became, since Cl has accepted one electron, so that one electron is one extra electron. So one extra negative charge is now occupying Cl. So Cl became Cl minus ion and Na became Na plus ion. And now, since these are oppositely charged ions, they attract each other and they have created NaCl crystal. तो NaCl क्रिस्टल स्ट्रक्चर में इसका नाम है कि दिस इज अ फेस क्यूबिक सेंटर्ड और फेस सेंटर्ड क्यूबिक क्रिस्टल FCC. तो बेसिकली अगर स्ट्रक्चर इसका देखो तो ये देयर आर इंटर लेयर्स ऑफ Na. सो 4 एटम्स Na के हैं, फिर 4 एटम्स Cl के हैं, फिर 4 Na के हैं, और उस तरीके से ये अरेंज्ड है NaCl. So that अगर a single unit cell, if you imagine, then basically that unit cell has 8 atoms on 8 corners, and on 6 faces there are 6 other atoms also. तो अगर कॉर्नर एटम्स Na के हैं तो ये फेस सेंटर्ड एटम्स Cl के हैं. इस तरीके से ये बने हुए हैं. Yeah, this is the crystal structure of NaCl. So here basically there are 1, 2, 3, 4, 5, 6, 7, 8. 8 cubes को मिला के ये स्ट्रक्चर बना हुआ है. So this is not unit cell. There are 8 unit cells in this crystal stone. उससे जो एक बड़ा क्रिस्टल, एक बड़ा क्यूब आपको दिख रहा है, उसमें अगर इफ यू सी देन यू विल फाइंड दैट ईच फेस इज सेंटर्ड. ईच फेस हैज वन atom. There are 6 faces. ये जो एटम है ये फ्रंट फेस का सेंटर है. ये जो एटम है ये लेफ्ट फेस का सेंटर है. ये एटम राइट फेस का सेंटर है. ये टॉप फेस का सेंटर है. ये बॉटम फेस का सेंटर है. दिस इज बैक फेस सेंटर. Therefore NaCl we call it is a face centered cubic crystal. On the other hand, as I said you that each has alternating atom. So this is Na, this is Cl. और उसमें ये भी आप देखिए कि Cl atom is bigger than Na atom. Atomic number दोनों का अलग अलग है, और उसमें भी Na has given up 1 electron, so it has actually now more attractive towards it. So Na atom से भी छोटा साइज Na plus आयन का है. Cl atom से बड़ा साइज Cl minus atom का है, आयन का है. And there are 6 nearest neighbor of each atom. So basically, if consider this Na plus ion, और तो ये 1, ये 2, 3, 4, 5 and 6. So these are the 6 nearest neighboring atoms of one atom. So this is the structure of NaCl. And because of this very strong electrostatic attractive force, this crystal is formed and there are no free electrons available, no free electron. तो सब आयन बने हुए और आयन बन के आयनिक बॉन्ड बना के they are tightly packed. So in solid form, NaCl is a very, very good insulator. So there is no free electron to move within the crystal. But then the question is why salt water conducts? को अगर मैं सॉल्यूशन बना दूं, पानी में नमक को सॉल्व करूं, डिसॉल्व करूं, it immediately starts conducting. Why? NaCl is purely insulator. H2O is also insulator. बट अगर उसका सॉल्यूशन में बनाऊं वाटर में तो इट स्टार्ट्स कंडक्टिंग. व्हाई? कोई बताना चाहेगा आंसर?
Due to hydrogen bonding, sir.
What happens?
like हाइड्रोजन बॉन्ड से जो एनर्जी प्रोड्यूस होती है ना, तो Na और Cl के बॉन्ड को तोड़ देती है, तो Na प्लस और Cl माइनस फ्री हो जाएंगे, तो उससे जो Na प्लस और Cl माइनस आयन से कंडक्शन स्टार्ट हो जाएगा उसका.
कैसे हाइड्रोजन बॉन्ड के NaCl को ब्रेक कर देता है? Which bond is strong?
Yes,
bond
sir.
or hydrogen bond? Answer me.
No sir, I don't mean say Na प्लस और Cl माइनस जब पानी में हम डालेंगे ना, तो जो H प्लस और जो H2 है ना, तो उसका H प्लस और जो O माइनस है ना, O माइनस जो Na प्लस है ना, उसको अट्रैक्ट करेगा, तो उससे अट्रैक्शन होगा, तो उसमें बीच जो बॉन्ड बनेगा ना, उससे एनर्जी प्रोड्यूस होगी, और वो एनर्जी जो H2 बहुत सारे H2O उससे जॉइंट हो गए, तो बहुत सारा एनर्जी प्रोड्यूस होगा, तो उससे जो एनर्जी प्रोड्यूस होगी ना, Na प्लस और Cl माइनस के बॉन्ड को तोड़ेगी. ऐसा.
Any other answer? बहुत अच्छा आंसर ये नहीं है. What is your name?
Yes sir.
बहुत अच्छा आंसर नहीं है. You attempted well, but answer is not correct. Any other answer?
वो
Sorry. बोलो.
NaCl की जो डाइल्यूशन एनर्जी होती है ना, वो NaCl का बॉन्ड तोड़ने से ज्यादा होती है. मतलब जब हम उसे वाटर में डिसॉल्व करते हैं, तो जो एनर्जी प्रोड्यूस होती है ना, वो
हाँ होती है.
हाँ. तो
The question is why solution of NaCl
आयोनिक बॉन्ड है ना, वो तोड़ने से ज्यादा होती है, इसलिए NaCl का आयोनिक बॉन्ड टूट के दोनों आयन की तरह पानी में डाइल्यूट हो जाती है.
यस सर. सो मीन्स जब NaCl को H2O में डालते हैं, तो मतलब H2O का OH माइनस और Na प्लस वो दोनों रिएक्ट करके जो मतलब वो दोनों और H प्लस और Cl माइनस के बीच का जो हाइड्रोजन बॉन्ड होता है, वो उन दोनों की एनर्जी कंबाइन करके जो एनर्जी बनती है, वो NaCl का आयनिक बॉन्ड की एनर्जी से मतलब वो क्या कहते हैं उसके तोड़ने की एनर्जी से ज्यादा होती है, तो वो टूट जाता है और Na प्लस और Cl माइनस आयन वाटर के सॉल्यूशन में मतलब वो सॉल्यूशन में मोबाइल चार्जेस की तरह रहता है, तो दैट्स व्हाई दे कंडक्ट इलेक्ट्रिसिटी.
चलिए का आंसर आप लोग खुद देखिएगा, मैं नहीं बता रहा हूँ, बट मैं ये आपके एग्जाम में पूछूंगा. ओके, तो अब आगे चलते हैं कि व्हाट आर मेटल्स। अगर याद करो तो 2-3 क्लास पहले हमने आपसे पूछा था कि मेटलिक बॉन्ड क्या होता है। यू ट्राइड योर लेवल बेस्ट बट इट वाज नॉट अ वेरी एक्यूरेट आंसर एंड देन आई सेड यू दैट आई विल नॉट टेल यू द आंसर बट वी will need the answer in some future class. So that is this future class when we require to understand what is a metallic bond. So the situation is that the metallic or metal atoms or the group of these metal elements such as जो नाम ऊपर में सब लिखे हुए हैं. So the uniqueness of this group is that the outermost electronic shell is only partially filled. Partially filled का क्या मतलब हुआ कि उनका जो attraction है towards their nucleus is not that great, and all these atoms are actually of bigger size. So Z बड़ा है इनका. जैसे देखो यहाँ कॉपर का एग्जाम्पल दिया हुआ है, तो कॉपर इज Z इक्वल टू 29. ठीक है. अभी जो हमने सिलिकन का एग्जाम्पल लिया था, सिलिकन का हमने Z क्या बताया था? एटॉमिक नंबर ऑफ सिलिकन वाज 14. और यहाँ देखो कॉपर का एग्जाम्पल है, इट इज 2 टाइम्स बिगर इन एटॉमिक नंबर. एटलीस्ट साइज में 2 टाइम्स बड़ा नहीं होगा, बट इट इज बिगर इन साइज. बिगर इन साइज का मतलब हुआ कि आउटरमोस्ट ऑर्बिट का जो फोर्स ऑफ अट्रैक्शन टुवर्ड्स इज न्यूक्लियस है, the force of attraction between the outermost orbit electrons towards its nucleus is much less than in case of silicon. Since it is much less and it is partially filled, so to acquire a good stable electronic or energy state, a better stable electronic state, what do these elements do? They tend to give away, donate. So this giving away is different from making an ionic bond. Ionic bond में वो अपने इलेक्ट्रॉन को परमानेंट छोड़ देते हैं. They don't recognize their electron. In this case, it is not that. In this case, they recognize that this is their electron. But still, in the crystal structure, in that you see of electronic states or charge, sea of charges, each of these atoms tends to leave or give away 1 or 2 electron and contribute, donate that to the 3-dimensional crystal space. ऐसा नहीं है कि किसी एक पर्टिकुलर एटम को दे देते हैं कि तुम ये ले, वो नहीं. There is a common pool. There is a common pool in which each atom donates 1 or 2 electrons. So suppose there is a crystal और there is a solid. तो मान लो गोल्ड का एक सॉलिड है, एक हमारे हाथ में क्यूब है, and suppose it has a density of 10 to power 19 atoms per centimeter cube. गोल्ड है या कॉपर है या सिल्वर है, जिंक है. तो मान लो 1 centimeter cube वॉल्यूम में. Now you should be in a position to visualize what 1 centimeter cube वॉल्यूम means. कितना छोटा वो क्यूब होगा. 1 centimeter cube वॉल्यूम में there are 10 to power 17 atoms of gold. Her atom, if donates 1 electron, just 1 electron to that 1 centimeter cube volume space, तो उस वॉल्यूम स्पेस में there are 10 to power 19 free electrons which are not at all attached with any single atom. So now you see the difference बिटवीन द NaCl आयनिक बॉन्ड स्टेट, जिसमें हमने कहा कि सॉलिड स्टेट में ये परफेक्ट इंसुलेटर है, नो इलेक्ट्रॉन इज अवेलेबल, नो इलेक्ट्रॉन इज फ्री, क्योंकि Na ने जो अपना इलेक्ट्रॉन छोड़ा वो Cl ने पकड़ लिया, वो अब उसको गिव अप नहीं करेगा, वो अपना घर छोड़ के उसके घर में जाके बैठ गया. So now neither Na has any disposable electron nor Cl is ready to give away its extra electron. But in the case of metallic bond or metals, what is happening is that each of these atoms gives or donates 1 electron or 2 electron each to the crystal, and therefore there are so many free electrons in that crystal available to move around. And certainly movement of an electron in one particular direction is flow of current. And we know hundreds of ways to make these electrons move in one particular direction. Randomly move करने में there is zero current. जो अभी मैंने आपको उसमें दिखाया फोनोन मॉडल ऑफ एटम्स में और सॉलिड, ये सारे एटम्स रैंडमली मूव कर रहे हैं, बट उसके कारण कोई करंट नहीं क्रिएट हो रहा है. But if we can give a direction to this movement of electrons in a solid or in a crystal, then certainly that crystal is said to be conducting. And that we know how to make those electrons move in one particular direction by creating an external bias, by connecting it to an external battery. So this is the metallic bond, how these metals and why these metals are actually conduct. So now we are coming to understand the band model of solid. Band, अभी जो हमने आपको दिखाया वो आज का क्लास जिस ग्राफ से हमने शुरू किया था. The isolated atoms have very precisely defined energy level. लेवल मतलब हुआ एक शार्प लाइन, और बैंड मतलब हुआ कि जैसे हम लोग तुम लोगों को ग्रेडिंग करते हैं, या जिसको 73.6 से लेके 69.5 तक मार्क्स है उसको AA दे देते हैं. So that is the band. But certainly each of you who are getting AA grade, the band of AA, each of you have discrete energy, discrete marks. But still मैं कहता हूँ कि नहीं, ये पॉसिबल नहीं है कि मैं सबको अलग अलग ग्रेड दूँ, इन सबको एक बैंड में रख देते हैं. So this is my AA band, this is my AB band, this is my FE क्या होता है जो भी होता है, DD band, this is my BC band. उस तरीके से मैंने आप लोगों को बैंड में ग्रेड कर दिया. Some of you are happy, some of you are not. Similarly here, when I create a solid from atoms, atoms do have discrete energy levels. अगर केवल एक स्टूडेंट की बात करूं तो उसको एक शार्प कोई नंबर मार्क्स आया हुआ है एग्जाम. बट जब मैं ग्रुप ऑफ 100 स्टूडेंट की बात करता हूं तब मैं कहता हूं कि यार इसमें 10 तरीके के बच्चे हैं, 12 को ऐसा है, 23 के इतने हैं, 34 के इतने हैं, इस तरीके से मैं उनको बैंड में डिस्ट्रीब्यूट कर देता हूं. So similarly here atoms and electrons also do behave like this, and we call it, or we try to understand it by a band model. So these all are very typical, basic, fundamental electromagnetic theory or electrostatic theory relations which need not to be spent much time on for teaching. For you understanding, ये सब आप लोग देख सकते हैं. So you, when I put these slides on my lecture folder, आप लोग ये देख लीजिएगा. It is very easy to comprehend, and you can understand this very easily. What this 14.6 इलेक्ट्रॉन वोल्ट मीन्स। हाइड्रोजन एटम के मॉडल से आया है। So when an electron moves from n is equal to 1 to n is equal to 2 सेकेंड क्वांटम स्टेट में या सेकेंड ऑर्बिट में, तो उसको वो कितनी एनर्जी रिलीज करता है या कितनी एनर्जी की जरूरत है। अगर 1 से 2 में जा रहा है तो आपको उसको हायर एनर्जी स्टेट में आप उसको ले जा रहे हैं। सो आपको यू हैव टू पुट इन, यू हैव टू पोर एनर्जी। और जब 2 से 1 में आ रहा है तो इट विल रिलीज एनर्जी बिकॉज इट इज बिकमिंग स्टेबल नाउ। सो इट इज now coming to a lower energy configuration, a stabler condition. So it will release that energy. That energy is 13.6 electron volt. So from there, here is the difference between electrical engineering and electronics engineering. That in electrical engineering, we have only one carrier, and that is electron. In electronics, there are two types of carrier. One is electron, or rather free electron, and another is anybody? Another is holes. So absence of electron is hole, और इसलिए होल का हम पॉजिटिव चार्ज मानते हैं। एंड दिस इज अ फिक्टिशियस पार्ट, एक्चुअली एग्जिस्ट नहीं करता है। ये आप नहीं कह सकते हैं कि इस एटम में इतने इलेक्ट्रॉन है और इतने होल है, ये आप नहीं कह सकते। But when we create a solid out of those atoms and we force them to take some electronic configuration, then by virtue of movement of these electrons, the space that is left behind by these electrons, free moving electrons, is known as hole, because there was an electron there. There was a negative charge there. So how a negative charge can disappear? By adding one positive charge there, equal positive charge. अगर डालोगे तभी negative charge disappear होगा. So we call that one hole is equal and opposite carrying, or carries equal and opposite charge of an electron. Electron has minus q charge, then a hole has plus q charge, and that charge is 1.6 into minus 19 coulomb. And expression of one electronic charge in energy term is electron volt. So charge is 1.6 into minus 19 coulomb, and electron volt, 1 electron volt is 1.6 into minus 19 जूल। ठीक है, यही रिलेशन है इलेक्ट्रॉनिक चार्ज और इलेक्ट्रॉन वोल्ट ईवी में। Fine. This structure you all know very well. This is the center is nucleus. The first orbit is n is equal to 1. The second is n is equal to 2, n is equal to 3, n is equal to 4. लोअर से हायर में अगर जा रहा है तो क्या एनर्जी वो रेडिएट करेगा, और उसके उल्टे अगर हायर से लोअर में आ रहा है, लोअर से हायर में जा रहा है तो क्या एनर्जी उसको चाहिए, तब वो हायर में जा पाएगा। आपको जंप करके ऊपर वाली सीढ़ी पे जाना है तो यू रिक्वायर सम एक्सटर्नल एनर्जी जंप। ऊपर से अगर नीचे आना है देन यू विल रिलीज सम एनर्जी। दिस इज जस्ट लाइक पोटेंशियल एनर्जी एंड काइनेटिक एनर्जी। You all are very much familiar with what we mean by Lyman series or Balmer series or Pascal series. तो लाइमन में है जो किसी भी हायर से n इक्वल टू 1 पे जो भी लाइन आ रही है, जो भी रेडिएशन आ रहा है, दैट इज लाइमन सीरीज। तो किसी भी हायर से जब n इक्वल टू 1 पे हम आ रहे हैं, whether it is from n equal to 6, n equal to 5, n equal to, कहीं से भी n equal to 1 पे अगर आ रहे हैं So that radiation line or spectrum is known as Lyman series. कहीं से भी जब n=2 पे आ रहे हैं that is known as Balmer series. कहीं से भी जब n=3 पे जा रहे हैं तो that is called Marsden series. Okay. And that is allowed for emission as well as absorption. So Balmer series of is this, जब emit कर रहा है, जब ऊपर से नीचे जा रहा है. And Balmer series of absorption is this, when n=2 से वो ऊपर के लेवल पे आ रहा है, तो एनर्जी वो absorb करके जा रहा है. So the same spectrum is for absorption and emission both. So these are for your understanding of atomic structure and how many atoms when get together, how do they behave. It's very important for you to understand that even by a single atom's addition, we are actually changing the electronic configuration of the system. Then go back and relate it with जो अभी हमने नैनो टेक्नोलॉजी में के डेफिनेशन में आपको 2 दिन 3 दिन पहले बताया था कि just by adding or dropping few gold atoms we are making that circuit open or conducting. वो कैसे हो रहा है? क्योंकि हम उसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन चेंज कर रहे हैं. इलेक्ट्रॉनिक कॉन्फ़िगरेशन चेंज होने से या तो एनर्जी इतने ज़्यादा स्प्लिट हो गई कि वो इंसुलेटर हो गया, और या एनर्जी उसकी इतनी कम हो गई, रिड्यूस हो गई कि इट इज एज गुड एज ए कंडक्टर. So just by changing, adding or removing few atoms, actually this complete game is of changing the electronic configuration, the overall energy equation or energy state of the system that we are trying to understand. And this is very important slide where I would like to conclude my today's class, is that if an atom is of a bigger size, z जब उसका बड़ा होता है, तो basically क्या है, n=1 and n=2 tend to remain very close to the nucleus, और जब n=3, 4, 5 होने लगता है तो they are actually 4 होगा तो और दूर होगा. Yes. तो 3, 4 ऑर्बिट्स में जो इलेक्ट्रॉन मूव कर रहे हैं, they are actually not very much affiliated or very much attracted towards their own nucleus. They behave like wanderers. अगर कोई बगल से कोई जा रहा है तो उसके साथ वो निकलना चाहेंगे कि चलो भाई हम इसके साथ जाते हैं. My parents are not taking care of mine. They are busy with some other smaller, my younger siblings. So when this situation arises, then what in a typical modeling of solid, what you actually do is that you consider the core atom, this closed system, you consider this as core atom, and you consider the outermost orbit's electron as a separated system. So this is one ion, this behaves as an ion, the core atom, and the remaining outermost orbit's electron is actually neutralizing that ion. So electronically, this will become Q plus ion, and this will become Q minus, because this is electron, so this become Q minus charge. In other words, how do we model such systems or solids that we consider the core as a hydrogen atom without electron, and that electron as the atom of the hydrogen. So, for any larger size of atom or atomic configuration, we can deduce that in a hydrogen-like structure. Hydrogen-like structure. Hydrogen-like में इसलिए हम करते हैं because hydrogen atom structure is very profoundly studied and closed in the textbook. कुछ भी ऐसा उसका aspect नहीं है जो स्टडी किया हुआ नहीं है, well understood. सारे एलिमेंट के एटम उतने अच्छे से स्टडीड नहीं है, but hydrogen atom is perfectly studied. So we try to convert any bigger size of atomic configuration in a hydrogen-like structure, and then we write all those electronic configuration to study if there is a possibility of conduction or if there is a possibility of non-conduction or insulation or in between semiconductor. All through in material science, what we are trying to do is that either we study the electronic property, or we study the optical property, or we study mechanical property, or we study heat property. इसी तरीके के properties को हम study करते हैं. Mostly in these days, electronic properties or electrical properties have come to the fore than any other property. और इसलिए हम लोग हमेशा या आगे जो भी कुछ 4-5 क्लास और बात करेंगे, those discussions will be around studying or manipulating or engineering the electrical property of the solid or the material that we are going to play with. Electrical property, क्योंकि मुझको switching करना है, मुझको current pass कराना है, मुझको current रोकना है. Whatever I want to do, I want to harness that atom or that solid or that material in terms of its electrical property, and so it becomes very important to understand where electrons are, where core atom is, how much that external outermost electron is connected with the core atom. If it is feebly connected, then it is quite possible to make it conduct. If it is very strongly connected, then it is too difficult to make them conduct or to use that material as conductor. तो उस तरीके से देखने के लिए जो मॉडल हम यूज करते हैं वो either it is a bond model or it is a band model. बैंड तब हम बात करते हैं कि एनर्जी लेवल में कितनी स्प्लिटिंग है. बॉन्ड हम तब बात करते हैं जब हम ये देखते हैं कि वो इलेक्ट्रॉन कितना स्ट्रांगली और कितना फीबली वीकली अटैच्ड विथ द कोर एटम. सो वी विल स्टार्ट फ्रॉम दिस स्लाइड और दिस स्लाइड in the next class. Okay? Any question? I stopped sharing. Start my video.
Hello, sir.
Yes, sir.
Sir, in the graph of relative spacing of atoms and relative energies, sir, in that graph, when in the state of 8n states and 4n electrons, you said that it is sp hybridization, right? But sir, in sp hybridization, s and one of p orbitals have equal energy and other two p orbitals have different energy. So how it is possible?
कौन सा S और P has same energy? नहीं, so
sir, any one of px, py, pz
has equal energy as S No, that is a wrong notion. In s orbital, it can accommodate 2 electrons, and certainly s orbital has lower energy than px, py or pz. But since there is a splitting that has started, so in the sp hybridization also, the s will first merge with px, or the lowest of the p orbital. जो 3 कंपार्टमेंट हैं p के, p में 3 कंपार्टमेंट है, each compartment can take 2 electrons of opposite spin, right?
Yes,
So let
sir.
us assume that there are px, py, pz. There are 3 compartments, and px has lower energy than py, py has lower energy than pz. Slightly, just slightly. तो जब स्प्लिटिंग होनी शुरू हो रही है तो हमने आपसे क्या कहा कि P भी स्प्लिट हो रहा है, सॉरी S भी स्प्लिट हो रहा है और P भी स्प्लिट हो रहा है. तो S जो स्प्लिट हो रहा है तो सर्टेनली वन लाइन विल कम लोअर, वन लाइन विल गो हायर. और P, तो P में देयर आर 3, Px, Py, Pz. तो P जो स्प्लिट हो रहा है जिसमें P की एक लाइन विल कम लोअर एंड P की दूसरी लाइन विल गो हायर. So that lower line is basically Px lower line, and the higher line is that is of Pz's higher line. So S and Px are first merging. So I don't know where you have got this notion that in sp hybridization S and Px have same energy, but if it is so, it means that even if within P, since there are 3 blocks or 3 compartments, they again have a different energy configuration. And the compartment which is closest to S compartment, क्योंकि S में तो 2 ही इलेक्ट्रॉन्स रह सकते हैं, इसलिए S में एक ही कंपार्टमेंट है. So the compartment of P orbital which is closest to S, वो शायद तुम मीन कर रहे हो कि वो that is of the same energy as S has, perhaps. I don't know whether I have answered your question or not, but जो splitting हो
Yes,
रही है
sir.
वो पूरे P की हो रही है, जो splitting हो रही है पूरे S की हो रही है. और splitting का मतलब तो यही है ना, एक एंड ऊपर जाएगा, एक एंड, अभी तक जो एक लाइन है उसको मैंने
Yes, sir.
स्प्लिट किया तो एक नीचे आ रहा है, एक ऊपर जा रहा है. So that is very beautifully done in that graph, and I suggest you all to refer to the book by Streetman Banerjee. ये एक किताब है. स्ट्रीटमैन की किताब है, उसमें बहुत अच्छे, उसी से मैंने वो ग्राफ स्कैन भी किया हुआ है. की किताब में देखोगे बहुत अच्छे से एक्सप्लेन किया हुआ है. और एनी स्टैंडर्ड सेमीकंडक्टर फिजिक्स बुक हैज एक्सप्लेन हाउ दिस हैपेंस. दिख नहीं रही है वो, घर पे होगी. But that graph is taken from Streetman Banerjee's semiconductor devices or semiconductor physics. Any other question? अब मेरे घर पे होगी शायद. Any other question? नहीं? तो चलो मैं क्लास क्लोज करता हूँ, भूख लग रही है मेरे को. थैंक्स. We'll meet on Thursday. Bye.